All right, so example 1 says list all possible rational zeros of that polynomial. So P, remember, is going to be the factors of the constant term. If I could spell.
You can't spell P?
I was putting constant and term together there. What number is my constant term? It's the one that has no x. So you could put -3, or you can just look at it as a 3, because either way we're going to do the same thing. So now, so when I go to find the factors of it, it's what divides evenly into 3, which would have a remainder of 0. So what's the smallest number that 3 is divisible by?
1.
And what's the other number?
2.
3, okay? So it's only divisible by 1 and 3, but what about -1 and -3? Is it also divisible by them?
Yes.
Yes, so we're going to put plus or minus 1 and plus or minus 3.
That's ridiculous.
Q, it said, are going to be the factors of the leading coefficient. So what number is the leading coefficient? Look for your largest exponent of x, and so it's the number in front of it, so the 4.
I actually, like I said, I'm just going to keep saying 12 until I get it right with it. I guess 12.
Alright, so what numbers will divide evenly into 4? Plus or minus?
2.
Okay, what else?
And then 1.
1. You said 2, and what's the other one? 4. I always start in order. I go from smallest to largest. So I always start with 1, and I work my way up to the largest one. Now, to find my possible rational zeros, we're going to have to take every P and put it over every Q. Actually, I'm going to write this below it. So the possible rational zeros. Now you need to find some pattern that's going to work for you, okay? You're going to have to take every P over every Q. So either take the first P and put it over every Q and then do the second P over every Q, or take the first Q and put it underneath every P, second Q underneath every P, third Q underneath every P. Doesn't matter, but pick a pattern that's going to work for you so you can be consistent and make sure you include every one of them. So I'm going to write it out to begin with. Alright, so first thing is each one of them is going to have plus or minus. I'm not going to do any reducing, I'm just going to write it out. So I'm going to start with my first P, which is a 1, and I'm going to put it over every Q. So I got 1 over, what's my first Q? Alright, so then plus or minus 1 over, what's my second Q? And then plus or minus 1 over, what's my third Q? Now, if I had more Q's, I would keep going, okay? Comma, now I'm going to take my second P, and I'm going to put it over my first Q. So I have 3 over, don't forget your plus or minus, 3 over what? Alright, then I have plus or minus 3 over my second Q, so 3 over, and then my plus or minus, and 3 over my third Q, which is, and if I had more Q's, I would keep putting 3 over all of them. If I had more P's, I would go on to the next P and put it over all the Q's, alright? So here is my list of possible rational zeros reduced. So you're going to reduce your fractions, and if you have anything that repeats, you only have to put it there one time. So the first one, what's 1 over 1?
1.
1 over 2. 1/2, right? 1 over 4. 3 over 1. 3 over 2. And then 3 over 4. And there is your list of possible rational zeros. Doesn't mean they're all zeros, just means that if that function up there, if that polynomial has a zero that's rational, it is in that list.